Hello, and welcome to today's presentation of Fighting Money Laundering with Machine Learning and Graph Databases. I have a few slides to set the stage, and then we can get into a demonstration. So first, I'd like to stress that the workbench I'll be demonstrating today, whilst it can be a standalone solution, it's not a rip and replace for those that already have existing systems in place. It very much so complements them. Today's AML investigation analytics systems provide only a narrow, static view of point transactions. They lack context, they have a heavy overhead in terms of human interaction, and they lack speed and scale. The TigerGraph customers leverage these existing investments in financial crime platforms, and where TigerGraph adds considerable value is by filling an important gap in the market, by providing an intelligence layer. The TigerGraph takes these hard-fought-for discrete outputs, be it suspicious activity or fraud, and then performs deep link analysis across all your data, connecting the dots in your data warehouse and any other disparate data sources. It uncovers additional connectivity to other potential bad actors, as well as those that display similar patterns of behavior. So integrating with platforms such as NICE Actimize and others results in broader, deeper, and dynamic views of transactions. Your AML analysts and investigators will experience a three-dimensional view of transactions. So by way of example, US Bank wanted to reduce their false positives with increased accuracy in real time for their AML investigators, and they wanted to derive more meaningful insights, uncovering deep link or, shall we say, non-obvious relationships. And so what they used it for was to identify connections between open work items in situations of interest, such as previous SAR filings or other open work items, to display the connections from one data entity to an entire ecosystem in an investigation, to allow analysts to identify the connections and situations of interest that have a higher probability of being a productive investigation, and to apply these insights to inform the creation or escalation of work items. So what I found interesting here is that a 10% increase in accuracy translates into $20 million in annual savings. Actual cost avoidance or potential fines is only 2 to 4 million. So clearly organizations are also protecting their brand reputation. And with TigerGraph, they're able to provide a more frictionless customer experience by reducing false positives and unwarranted investigations. So we start from a baseline and increase accuracy by 6% with graph databases and in-graph machine learning and graph algorithms. Now that alone is a significant step forward. 6% can translate to millions of dollars for any large financial institution, as I'm sure you're aware. And then we get an additional 5% more with visualization that enables humans to understand and identify areas for improvement and to drive more effective machine learning. So lastly, just a little bit about us. Gartner are a big fan of not just TigerGraph, but graph analytics as a whole. They named it a top technology trend in 2020, and again in 2021, foundational to the only one that was foundational to the remaining 9 trends. We're available on all marketplaces and there are on-premise options as well. So let's get straight into the demo now. So first of all, this is an AML investigation of financial crime toolkit. It's been built from the requirements of our customers. It's highly configurable, not at all rigid, but it's up to you to put the finishing touches on this for your organization. All right, so here we have the top level dashboard, and the idea is to provide a high level overview of KPIs. Immediately we can see a benefit of graph, which is detailed and aggregate level graph analytics with real-time filtration. As events come in or you want to change the date range, then the figures here in the real app will immediately update. So this is a click through. So from here we can drill down to regional views or transactional views. Let's have a look at the map. So a high regional map with filtered analytics. We can interact directly with the screen by using this flyout filter on the right. And this is part of the in-context engagement for an investigator with complex data. So in the real app, all changes to this filter are directly applied to the view. And, to, for example, reduce noise by only considering certain types of fraud above a certain threshold. So no multitude of reports, no need to involve data science or the reporting team, full autonomy for the investigator. So let's have a look at this red zone here. The spider chart highlights the top risk companies showing here, Wallace Cargo, and where it exceeds thresholds along the various dimensions. Again, contextual display of analytics, immediately investigate, an investigator can get a breakdown of the risk and perhaps make an early assessment of concern. So the quick action menu under the spider chart, part of a rapid engagement flow, going to more detail or saving this view directly to a to-do query list. And since this view is a live query, the database can rerun the query at any time. So it's real-time graph analytics. Alternatively, we may want more detail. So this shows the next level of detail on Wallace Cargo. On the left, we have transactions in order of aggregated risk score, queried directly from the database based on the active filters. On the right, we have the network view, which already puts two of the highest risk transactions into context. This kind of contextual linkage is easy for a graph database and hard for conventional or relational data stores. Note also the network view is annotated to draw attention to areas that may deserve attention by drilling down further. Or indeed, you might want to have a look at a flow view. And you may need to have an extended view of the network that's not available, but nevertheless, with sufficient data, it is possible to directly query and analyze summary flows across a range of counterparties, in real time. So moving on to transaction detail, this shows selecting a number of transactions and saving that as a query. And just to reiterate the point that this is a view on a live database, not just a static report, making it easy to regenerate result sets. This allows the investigator to follow the evidence trail in any order without losing other possible lines of investigation. A fast analytic database like TigerGraph powers this kind of capability. So let's add this to the query list. We'll have a look at that query list. So we can see it's been added and saved. And save queries to show that they can be stored and modified. Also an example of how queries can become part of case management. So where existing case management systems are to be used, and the query can be expressed as a web link, easing enhancement of existing systems. So let's take a quick look at these queries, kind of a query workbench. So in applications like this, it's perfectly possible to express queries in a form-like fashion. Your investigators might not have that technical querying expertise. The view here is to select the data sources for the query, as well as to add filters. So let's have a look at the map view. Components like the map view are offered as part of the UI toolkit. To make the building of these kinds of apps rapid and available for in-house or third-party resources to compose into apps like you see here. So going to the network view of the results, we can see that the network view UI component, as before, it has the same drill down capabilities we saw there, including the filtering flyout menu on the right. So drilling down to the detail. As before, all of the filters are live, so results are immediately seen. And again, this kind of analytic power provided in parallel across large heterogeneous linked data sets is a unique capability of TigerGraph. So this enables agile investigation flows, with corresponding improvements in performance. So for example, over here, we can change the layout. And having got this result, we now have some clarity about the extended network focused around Sharon Kyle. She was the riskiest person involved in Wallace Cargo. And her extended network is queried here. So it's a common question, can we find people who are similar to a selected person or set, group of people? And absolutely. And one can imagine this as a discrete output from your existing financial crime platforms. We're taking that single discrete output and offering that intelligence layer to link and find more. So let's try that. Let's find somebody similar. And a host of different graph algorithms are available, out of the box with TigerGraph. And these are just a few. So we'll try similarity detection. And Graph is really, really good at rapidly finding similar people or entities in the network. So here are the results, and there we have it. Ellen Caldera has a similar profile to Sharon Kyle and is part of the previous network. And so let's say we want to now take even a deeper look into it. So we can send this to a machine learning notebook. And this is made easy by having standard integrations which are understood by the majority of data science tools out there, REST API and the JSON. So here's an illustration of a data science machine learning supported UI. The data selected is augmented with the graph implemented scores and features here selected on the left. If the notebook is available, we have standard data science Jupyter Python here, then previews can also be displayed to filter which metrics and attributes are sent. So TigerGraph allows for this dynamic querying, again, making these kinds of screens easy to construct. Here's another example here of an external notebook. And again, we can see the graph features here. So moving back to the dashboard, we can also go and look at at a more detailed transactional level. So this is giving you the top level information that starts a transaction-led investigation. On the left is the specific information. On the right is a map contextual view of the location of the actors involved in the transaction. The influential factors are calculated here in real time. You have a triage button appearing on the bottom left for rapid classification. And you may want to get the network view. So this is the top level network view of the transaction. And note, we're already bringing in some context. For example, to show that 3 out of 9, 33% of transactions in this period had issues. And the graph directly links these together exactly as we see here, making such queries really fast and efficient. On the left is the specific information. Again, triage buttons appear for rapid classification and of the transaction. And the network views allows direct drill down. So, for example, expanding these group transactions. So this drills into the individual transactions here, and the need for a scalable graph database is important here. Given there may be many millions of transactions that need to be stored. So on the left is the specific information around flagged and related transactions, providing some context. This shows that problematic transactions seem to be grouped on a particular target, financial institution, city center bank. And the next question may be about the timing of the transactions. Are the bad transactions grouped, suggesting a possible account credential theft? And we can look at the timeline of transactions. And indeed, it shows that the problematic transactions seem to be grouped, but it's only 3, and there are other transactions mixed in there. So possibly this is not enough to warrant a full investigation, but needs monitoring. So fortunately, since what we are seeing are live queries on the database, it's relatively straightforward to define alerts, such that any changes are brought up to the dashboard level. So here we want to set an alert involving Margot Smith at City Center Bank. And the approach to setting a pattern here is common. The relevant entities are highlighted, and a pattern is defined as a query that looks for changes in the defined sets. So here we have the source company goes Brighton Inc., sender is Margot Smith, transactions are above a certain threshold, and the destination bank equals city center. So let's set that pattern alert or query. And this customer wants alerts to trigger actions, right? So that becomes the application's responsibility. The interesting point here from a TigerGraph point of view is that the rules are stored directly in TigerGraph, so that complex queries obeying these rules can benefit from TigerGraph Engine's real-time analytics and are directly adjustable by the team. So just to note as well, fine-grained permissioning at the database level can limit this capability to those who need it, as well as for audit changes. But ultimately, if the pattern is fired, then it feeds into that top level dashboard screen. And so that's it. Thank you so much for your time, and I look forward to the Q&A.